don't know what an inverse trig function is. That's okay, we're learning. So, does anybody know what we mean by inverse operations in math? We talked about inverse operations before, Evan.
It's like the opposite of a certain function.
The opposite of a certain function, it undoes it. So if I say addition, what would be the inverse operation for that? Subtraction. That undoes the addition. And so if I said subtraction, what would undo that? Addition. They're inverses of each other, right? Okay, so if I say multiplication, what's the inverse of that? Division. And vice versa. And if I say square rooting, what would be the inverse of that? A square. Okay, I'll just write x in the second there, just to show kind of something being squared. Okay, so we have all these operations, and we have inverses of them as well. So just like we have these trig functions, which are operations, then we will have inverse operations. So if sine of angle A is equal to x, if we have sine of angle A equal to any x, just like over here on the board earlier, we had like tangent of 60 degrees was equal to 6 over x, or if we type into our calculator sine of 60, we would get a certain decimal to come out. Same thing there. If sine of angle A is equal to x, then we'll say that A, the angle A, is equal to the inverse sine of the number x. Yes. It looks like capital A equals sine to the negative first x. But what that notation means, that -1 just means it's the inverse function. That's how we denote or say or write inverse sine. We read this as inverse sine, even though we write it sine to the -1 power, the first power. But we read it as inverse sine. That's just saying it's the opposite of that. Opposite function. So we read this as the inverse sine. So angle A would then be equal to the inverse sine of x.
So would this be with the cosine? Would it be A equals cosine -1?
Inverse cosine of x, yeah. So in the next one, if cosine of angle A is equal to x, then angle A, the angle measure, would be equal to the inverse cosine of x. So the thing is with these trig functions is we use them on angles. We use them on angles to find measures, to find lengths. We use them on angles to find lengths. So this would be using lengths or the actual decimal or fraction we have to find the angle. So it would be going the other way. We'd be looking to find the angle where we started. So it would be undoing it. Let's go back to the start of the angle. So tangent of angle A is x, then angle A is equal to inverse tangent. Let's see if we pronounce that inverse tangent of x. Now, mathematically, how this would work. Mathematically, how this would work is if we had sine of angle A, just right down here, we just said, oh, sine of angle A is equal to x. Okay, no, sine of angle A is equal to x. We would then, just like if you had something being multiplied together, or like on the board earlier when we had something like this, where we had, what was it? We had like cosine of like 40 degrees is equal to like, what was it, 8 over d or something? Something like that, okay? Then we multiplied both sides by d. We did something to both sides to undo that. We did the inverse operation to both sides. So here, we'll say the inverse operation of sine is inverse sine. So we'll take the inverse sine of both sides. And it's a little bit hard to write here, all of that. So we'll just kind of write it up here above it. But know that we're still taking it in front of it because we write it before it. Just like a square root, you write it before it. Not like you write this and it's like, oh, that's the square root of x. That'd be weird. Okay, so we write it before it. So what happens is just like the multiplication and division, they undo each other, so we cross them out, or addition and subtraction are the same thing, undo each other, they cross each other out. As long as it's sine and inverse sine, they will undo each other, and we'll be left with just the angle. Angle A, whatever measure that would be, is equal to inverse sine of whatever x is. So that's how it would work mathematically. Now we'll try this with numbers so it makes a little more sense. Okay, we'll try it with numbers so it makes a little more sense as well. I'm not just going to keep it this abstract. So if we go to the back here, okay, we're in the home stretch. We're in the home stretch of these notes. Yeah, this is it. This is it, right? Okay, we don't even have a back of this page. This page is not double-sided, Kaylee. This page is
I
not
just
double-sided.
checked too.
Yeah.
She had to be sure.
Are you pretty excited about that?
Yeah.
Yeah, okay, I hope so. Good. So here, we need to find angle C if sine of C is 0.24. If sine of C is 0.24, so if we write that down, to give it some more room maybe. Sine of angle C is 0.24. How could we get C by itself? How do we undo this sine? We're trying to find the angle. So it's not times it, it's not multiplied by it, but we take the inverse sign. Very good. We take the inverse sign. So you don't multiply it. Just like we don't say that when we square root something, we don't say we multiply the square by the square root of. If you take the square root, you just say we take the square root. So here we take the inverse sign. If we do it to this side, we have to do it to this side of the equation to keep that balanced. And then inverse sine and sine undo each other. Inverse sine of 0.24. You might be wondering, well, Mr. Costa, that doesn't help us at all. We are no closer than we were. Well, awesome math students, thanks for asking that. Okay, so if you have one of my calculators, awesome. If you don't, I'm going to be handing you one real quick. Okay.
That was real close. You go to two.
Yeah, you'll go to your second. So if you look right above the sign button, what do you see?
Inverse sign.
You see that inverse sign. You see that inverse sign notation there. So if you push that second button at the top left of those calculators, on my calculator, you push the top left of those buttons.
Wait, where? Oh, second.
Okay, you push that little second button. It's in that lighter blue. It's in that lighter shade of blue on those.
Equals
13.9.
Yeah.
Okay. So if we give if we give the really long one, for example, C would be approximately like what, Ian? Go to 4 decimals on this. 8865. Now, if you got something different than this, rounded out to a lot of decimals, please ask so I can help you out real quick. Did anybody else get something else? Did anybody else get something different? Anybody else get something different? Okay. Did you get everything now?
Yeah.
Awesome, yeah.
Is this to like plug in your computer so you can show it?
That's one thing you can do. Otherwise you can do things like you can install programs on there. Like when I was in high school and I took a stats class, if we had like a TI-84 on my TI-84, what we could do is our teacher was able to put on there a stat program, so one that wasn't normally on the calculator was capable of, and so we were able to have additional programs. Yeah, you can get a lot of games in those. So. Unlike some of those, yeah, unlike the one that like
Texas.
you guys could probably get like
Super Mario.
Pokemon, like one of those old Pokemon.
Definitely not
later. No, super not that. Probably not even your Casio. I don't think. But so anyway, but let's actually we'll normally be told what to round this to, but here if we're rounding an angle, we can round to the nearest degree. So what would be the nearest whole degree?
13.9.
The nearest whole degree.
Oh,
14 degrees. Because we're dealing with angles, so we're still in degrees, okay? We're dealing with angles, so our label's automatically degrees. Now, would this have worked originally going back in the problem, going back to the setup? Since this was sine of C, could we have taken inverse cosine? No, we need the inverse for the same one it is. So if it's sine, we need inverse sine. If it's cosine, we need inverse cosine. If it's tangent, we need inverse tangent. You don't mix them up. And as long as you have the sign that same inverse of the trig function, they'll undo each other. So I want you guys to do number B, or letter B, excuse me, number B. I want you guys to do letter B on your own, and then raise your hand when you're done, or have questions, okay? Raise your hand when you're done, or have questions on letter B. And once again, go to the nearest whole degree. Very good. Go ahead, check.
What? What did you get?
People raise their hands. Okay. Yes.
How did you get that?
Go ahead, help check. Yeah. Awesome. Okay.
What? Okay. Put it in a calculator. Yeah, you did do that. There you go. I don't have a. I mean, I have one. Can I? Can I use
Actually, I'll highlight that.
I got you right.
What? You're the big killer.
Oh, good. The only thing that's getting slept on is you. When you're sleeping at home, quiz board.
Alright. So, what did we end up getting here?
68 degrees.
Angle CU is approximately 68 degrees. Okay, after we did all the math through here, we got 68 degrees. Now we had to use inverse cosine, right? We didn't use like inverse sine or inverse tangent, that'd be weird too. We use inverse cosine. But if we did, okay, for example, if we had used inverse sine, I want to look at something, okay? Adrian, when you did inverse sine of these same numbers, what did you get as your angle measure?
I did that. I got like 22.
Okay, you get 22. Okay, Tibbs would be proud. So if you did inverse sine, if you did the inverse sine of 0.37, then you would get 22 degrees about. Now, what knows about 22 and 68?
No, they're not the same.
They're not the same?
They're
Right.
46.
It's like,
It goes up by 46.
Okay, it goes up by 46. 68 is 3 times bigger. Approximately. Okay, do they add up to something?
Oh,
90 degrees.
So let's think about this. If we have a right triangle here, and if, because this is only true for right triangles, if we know one of the angles is 68 degrees, do we know the other one has to be 22? So if we find one angle using inverse sine, and the other using inverse tangent, inverse cosine, they better match up. You'd hope they match up because we know that, because of how these two angles work with the right triangle. So if this one's 22, this one has to be 68, or 68, they have to be 22. So it'd be like that in a right triangle. Pretty neat stuff. Okay, so I digress. Let's look at example 2. So if we need to find the measure of angle Q to the nearest tenth of a degree, wait, how in the world are we going to do this? This is quite the progression, isn't it, Mr. Cossel? Well, not quite. Awesome, math students. Thanks for asking. Okay, so on example, on angle Q.
Trevor's not in the apartment to talk to himself.
No, Trevor talks to himself a lot though.
do you?
No.
Probably.
Sometimes.
You just did. Yeah. You live.
Well, yeah, but that was like fake dialogue.
You can't hear the voices.
You don't like take your lesson before you get to school.
Voices.
You don't get there to fly.
I looked over on the board. So I prepared them like about a week ago. Okay, so angle Q comes back. Okay, and we need to find angle Q, but we don't know any of these other angle measures. By the way, this is the right triangle. We have to know it's the right triangle. I should draw it right there. And draw that in there. Make a note for next year.
He's already knows your Titus.
Whoa.
You have eyes and I too well.
Yeah, that's
You
you started
literally
talking
like
like
talking
him.
yourself back there and you went, okay.
At the beginning of
Every day.
freshman year, he told us that if he talks too fast, we're supposed to do this.
Yeah.
Slows down.
Hey, so.
What?
Thank you. We know two sides of this right triangle. Which two sides do we know? Based upon angle Q. Based upon angle Q, which two sides do we know? Very good. Adjacent hypotenuse. What's our acronym for trig functions? Spell it for me. Beautiful. Which one deals with hypotenuse and adjacent? So what operation, what trig function would we use? Cosine of angle Q. What is cosine of angle Q equal to? Adjacent over hypotenuse. This is how we set up. We literally set up the trig function like normal, just like we would have, except for now, our unknowns are angle rather than one of our side lengths. Now, we say, okay, how can we get this by itself, though? How can we get, so we need to get Q by itself. Inverse of cosine. We take the inverse cosine of both sides. We need to undo cosine. We need to undo cosine to get Q by itself. We don't divide by cosine because it's not being multiplied with Q. We undo cosine. We take the inverse cosine of both sides. Inverse cosine and cosine. Those undo each other, so we're just left with angle Q. The measure of angle Q is going to be equal to the inverse cosine of 8 over 15.
Yes, you can.
So, how you would put this in a calculator, awesome math students, thanks for asking. How you put this in a calculator is you would type in, you would do your inverse cosine first, and it would pop up a parenthesis right after that, right? So you do 8 divided by 15, and then you end your parenthesis.
Wait, what? Oh,
8
8?
I got it.
Not 8 slash 15 or just 8 divided by 15?
If you, when you put divided, it'll put a slash. That's what it puts in your calculator.
I got it.
Okay? But here, where are we supposed to round? Okay? So the measure of angle Q is approximately what? 0.8 degrees. Did anybody not get that as their approximation for Q? Anybody not get that as their approximation for Q? Okay, cool. Questions on example 2?
Can't we just put 15?
No. It said nearest center degree. If it said nearest degree, then sure. But it doesn't.
Can you pick a single direction?
No. Right. Left. You said to pick a single direction.
Yeah, like the direction.
Yeah, right.
Direction, south, east, west, southwest.
One direction. Up and
That's what
down.
makes you beautiful. Okay. Example 3. Our last example of this note package. Woo! Okay.
Not even 255 up.
Yeah, I've been running into that. Okay. Hey. A road, driving road, rises 10 feet in a horizontal distance of 200 feet.
Rises.
What is the angle of inclination? Can I get a volunteer to draw a picture of what this might be? Ian.
Not drawing a scale.
Unless it is on the scale, then it would be.
I guess unless it is, then it would be, yeah.
Can you explain how you
Yeah, vertical,
rise
horizontally.
No, it rises 10 feet in the horizontal distance of 200.
Wait, rises 10 feet. Yeah.
rises 10 feet?
Horizontally.
Oh.
I agree with that.
It's a little
Wait.
off. I disagree with that. rise. Yeah. So it rises 10 feet.
So the 10 foot's ready because it's.
Yeah.
Oh,
200 is a light.
Yeah, the finger doesn't work. This is Mrs. Olson.
This Johnson is really happy for you and that the fact that you're.
No,
Fish
she was-
can't be
She
lit.
was PO'd, man.
When
She was like, her board doesn't work, just took muscle work. So, she was like, good for him, he can do that. I'll do that.
Unfortunately for me, it's really hard to do the brush.
Yeah.
her board still doesn't work. Oh, that sucks.
Wait.
So I need back. Ah! Put a right angle there somewhere. Ian!
Oh, I was like, you can
Okay.
have
Okay,
your
that's good. That's fair.
Where did he put it?
Technically, you probably like how like
Okay, Ian, explain your picture.
The road rises 10 feet, so as it's going up, it's 10 foot. So it's gonna go up 10 feet, and then the horizontal distance of 200, horizontal 200 feet. So they look the same.
But they're not.
They're not.
Okay, because it's not on a scale.
Yeah.
So we go off the labels, right? Okay.
I'm being that tasty.
There you go. Slap on the back. Okay. So that's how this works. If it rises 10 foot in a horizontal distance, it doesn't mean 10 foot in a horizontal distance. No. Over the course of 200 feet, the road goes up a total of 10 feet, but it goes up that slowly, gradually, at a slope. Okay? At a slope of 1/20, 0.05, or yeah, 0.05, whatever. Okay? Hey, so we need to find the angle of inclination. Do you remember angle of inclination, angle of elevation, and angle of depression? Okay? Which way would? Yeah, yeah, yeah. Yeah, I like that.
What
I
is
live it.
Okay.
Okay, so inclination. What word do we think of when we hear inclination?
Incline.
Incline. Incline means, okay, you think of bench.
You're half
You're going
here.
up. Okay, with respect to horizontal distance, you're going up. So which of these angles would be our angle of inclination?
The bottom.
The bottom right, this angle right here. Okay, we can call it theta. If we don't know what to call it, we can call it theta.
I'd rather call it a letter.
It is a Greek letter.
Okay, I'd rather
Wait,
call
how
it
is that inclination?
I'd rather call it pi.
Because this is the angle that it inclines at.
Oh, okay.
It's our angle of elevation. Okay, so
It's the little pill.
Quick question,
The little pill
Tassel.
that goes up,
It's the pillow.
and it helps
Is
you
pi the actual
spread
name for
because
like
it's up there.
Greek letter?
Oh wait,
What?
I can't do that.
Like is pi the actual name for the Greek letter?
a pi. Yeah.
Pi's a food.
It's like hold my breath.
I like pie.
Alpha, beta,
I know where the
theta.
angle
No,
of
we're not gonna do
depression
theta. We're doing what pi.
is. Angle of depression is right outside.
Well,
What
okay,
would
so
you
my
like if
arms
it's
like
like
over
this?
here.
Or if you had like one over
Wesley.
here.
Oh.
Okay. Hey, listen up again, please. Listen up again, please. From here, I want you to solve this.
But I don't know what it is.
Okay? I want you to solve for theta. We have to use inverse trig functions. Hint. I want you to solve for theta. And once you do, please raise your hand. Or if you have questions, please raise your hand.
Oh.
Hashtag lol.
Deal with this every day.
And you just hear the entire class go silent. Shut Adrian.
You guys keep me young. Not good.
I'm not gonna.
What is young?
It's all
What
relative.
is young?
As in, I have relatives that are young.
Wait.
Of my siblings. I have cousins too.
I'm number 7
No.
of like
My
I have
Oh, I'm
everyone.
number one of like three, but it's funny.
Except for Owen. My mom met your grandma a while ago.
Yeah. Oh, do you
Runs
know?
them.
Shoot, Christian Birkin.
Yeah.
Yeah, that's my cousin.
Okay. Yeah. Because your grandma was Vicky?
Yeah.
Yeah, my mom's like, I ran into this Vicky Erking at Runza today, and she said that her granddaughter goes to class with Hazio, the teacher. I'm like, that's pretty neat.
Yeah,
No way.
Erking is my cousin.
Yeah, he was I hung out with him a little bit as like a little kid, like in elementary school. But then we kind of drifted apart.
Yeah, well, okay, so you like look like my aunt. So you look like my aunt's like ex-boyfriend. So we sat there for like 20 minutes, like, wait a minute. And then we were like, wait, no, that's not. Yeah, so then my mom had told my aunt about it, and we were like, it's crazy. And she's like, oh, well, you should ask him if he knows Christian. And so, yeah.
That was good.
Oh, the past is very important.
Okay.
You look like my aunt.
Okay.
Boyfriend. Don't pause, definitely. What do you know?
It's not hard.
Oh.
You got this.
My bad.
Make sure we're working here. Make sure we're working here.
I don't think there's only enough.
How is that right?
So if this side is really small compared to this side, wouldn't this angle be a lot bigger than this one? Yeah. Yeah. So it kind of makes sense. Yeah. Flashlight. Remember, if you're showing like a flashlight on the opposite wall.
It doesn't tell me what's around it too.
He's trying to get your problem. What are you around? Cool. Do you guys want to check? Dope. Thanks. Sure. I think it means.
I'll check you, Jacob. I got you.
I got it.
You're
You better
correct.
not check. Do we do the A squared plus B squared? I will throw it in.
You put your hand up. I got it.
Here.
Yeah.
Whoa. We were trying to find a thing.
You like that? See.
What?
Aubrey, help us. No, help me. What do you want? Thanks,
Freshman.
Okay, well, okay. You're nice.
Okay,
You're
so
nice.
next year we're
You're nice. Oh, yeah. I know, but I mean, like, you never really know where
Well.
Oh, yeah.
You'll get to do that next year. Jacob would be the first to get one.
Okay, Riley.
Voice it off, please.
Yeah, you're
Voice it
all-
off.
oh, you're
Quiet back there, please.
I could go like, is 30 right? I go, no. I was like, did you use tangent? He goes, did you use the inverse? And he goes, oh.
There you
Hashtag
Everything
you like.
Actually,
I started
So,
saying
you wanna
food
text
so
these
much,
handsome
and it
great?
like
By all
drives me
means.
crazy.
Text
I'll go,
these hands.
somebody will say
Oh,
something,
wait.
I'll go.
It's super
And
solid.
then I'll
Man,
go,
out of the
if
blue.
someone says something that you
Yeah.
don't have a response to, you're gonna have to be
Filler for every round up to
And
that.
what?
I don't know what to
People
say.
are like, I don't like that word.
You see that small pile there?
Like, it's too big that, like, it's
Yeah.
everyone. It could be like, like.
no. Evan, no.
He's gonna focus all the time.
He said my paper was like a jelly donut.
Now, it's not a thing, it's a bad thing, it's a How does Facebook?
Oh, is it?
I don't
Mike.
know. How does Facebook?
Wait, what is that?
Okay. Did everybody have theirs checked?
Yeah.
Yes, I have a pink.
What?
Dummy.
What was that about?
You have a heart. Type of video.
Yes, I
Okay,
know.
check it by who?
How does Facebook do it? Like,
Okay, so our theta ended up being approximately what to the 10th?
2.9.
Now, if we look at this, you might say, well, that's a weird angle to get. Well, let's put it in perspective. Would it make sense for this to be 2.9 degrees, whereas like this would be 87.1 degrees, where like this angle would be much bigger than this angle? Because this opposite side is huge compared to this. 220 makes sense the opposite angle would be way bigger than that one. Way bigger, okay? Questions on this? Yeah, that was close.
I get coffee every Monday and Wednesday before third hour, and it wasn't open. And I said, "Excuse me, but I need my sweet soda."
But you have to keep it hustle.
Yeah.
I think you have an hustle. Hey, so what is this gonna do? Friday, we'll talk Friday with your next class.
Oh.
So this is my only
Okay. Hey, so let's use this work time wisely and make a good dent in this homework. So that way, as you have questions, you can ask them now because you guys know my study hall is going to be crazy. Okay, we're busy, crazy busy today.
I don't know about
What was that?
homework. You never know if there's gonna be a snow day or a bug day.
So my study hall is usually pretty crazy, so let's use this time wisely to work while you guys have me here to ask
What's
questions.
that flying in your hair?
I can do it just fine, and then
A what?
I get that.
Bed bug in your hair?
What's up?
Ew.
Yesterday in world geography,